A car's as good as dead without the electric energy from the battery. Not only does a car battery generate enough juice to start the motor, it actually makes its own when the motor runs. That's because this plain-looking box accomplishes two diametrically opposed functions using exactly the same ingredients. It generates electricity and it accumulates electricity. The battery manages this incredible feat by exploiting reversible chemical reactions. Okay, so how does it work? A car battery has a positive and a negative terminal. They're connected to the car and send a flow of electrons to power the wipers, headlights, radio, air conditioning, and most importantly, the engine starter. Inside the battery are 6 small energy-producing units called cells. Each cell has 2 sets of electrodes. They're made of 8 overlapping metallic plates, for a total of 16 per cell. Together, the plates form a compact grid. The bigger the grid's overall surface, the more power it generates. The positive grid, covered in lead oxide, carries electrons in. The negative grid, covered in lead, releases electrons. The plates soak in a chemical bath. 65% water, 35% sulfuric acid. Volatile stuff. If you're not careful, a drop of it will eat through your clothes and burn off your skin. But the key to the car battery is all those powerful chemicals reacting with each other inside the cells. Reactions repeated as the battery drains. The bath of water and sulfuric acid acts as an electrolyte, a substance that conducts electricity. As the battery discharges or unloads electricity, the acid bath reacts to the chemicals on the plates. The lead covering one cell grid and the lead oxide covering the other. Dipping them in the electrolyte bath releases particles called electrons. When they start racing in the grids, they create electricity. As the electrons race from the positive grid in the first cell and out the negative grid, they produce 2 volts of electricity. The lead and lead oxide covering the electrodes have been chemically transformed. And when the electrons from the first cell zoom into the second cell, they pick up another 2 volts, for a total voltage of 4. By the time the electrons charge out of the 6th cell, they have a combined voltage of 12. That's a fully loaded car battery with enough juice to power the starter and crank the engine. Once you've squeezed out all the juice to start the motor, the fuel system takes over and keeps the motor running. The car's alternator takes over the rest of the electrical chores. Time for the battery to juice itself back up. It recharges by reversing the chemical reactions. Electrons coming from the car's alternator now enter the battery through the negative grid of the cells and come out the positive side. The chemicals on the grids go back to normal, and the battery is recharged and ready to put out another 12 volts of electricity. That is, unless you happen to leave the car lights on overnight. In that case, the chemical reactions move in one direction, draining the battery, which never gets a chance to recharge itself. The inevitable result is a dead battery.